Hi friends, welcome to the next session on this series on operating systems. Now let's get into some details about the operating system functions. As we discussed in the beginning of this series, that the operating system performs several functions like process management, memory management, disk management, networking, security, device drivers, and user interactions and all that. So let's see what all it can perform. So under the process management, process basically is a program in a running condition. So as long as the code is there in the backend, that is secondary memory, it is called a program because it doesn't have any state, doesn't have any action, it's just a code. But when we start executing it, then this code comes onto the main memory, and once it comes onto the main memory, it is named as a process because this process contains, along with the code, the memory to store the variables and the memory for the stack and all that. So the whole thing which contains code, then the memory for the variables, the contents of the variables, and the stack all together will be called a process. So under process management, creating a process, that means getting the program from the secondary memory onto the main memory. That means before getting into that, we need to allocate the memory and then decide where what goes and all that, and allocate the memory for various variables defined, and allocate the memory for the stack and all that. This whole thing is done under what we call creating a process. And once the work is done, then we need to free the memory, we need to give the space for others to occupy. So the deletion of the process also under the process management system. When we are trying to run multiple processes on a single process environment, or multiple processes on a single processor environment, then any given time only one process can be active and all other processes have to be inactive. Then when multiple processes require the service of the processor, then it cannot be given in any way we want. It has to be done in a proper way, and that proper way of providing the fair chance for every process to get the opportunity to use the processor and get its work done. That's what we call scheduling. So we see various types of scheduling algorithms available under the process management. Then we need to synchronize the various processes. If one process wants to communicate with another process, then there has to be some great synchronization. Say if two processes are trying to communicate and one process wants to send a message to another process, then the other process should keep waiting till the first process sends a message and the second process receives it. So there has to be some synchronization between the two processes and multiple processes if we are working in such an environment. Then all the synchronizing activities and communication activities and all are taken care by the process management. So the next important action is about main memory. Yes, we do have limited memory available as a main memory, and this limited memory we should use to full extent as much as possible. So there is a requirement of allocating the memory for each process. So how to allocate the memory? Under process management also memory allocation is done, but it just tells that how much memory is required for the code, how much memory is required for the variables, how much memory for the stack and all that. It doesn't care where the memory is available and all that, but the memory management is the one which verifies the availability of the memory and then allocates the various components, the memory for the various components. And this is taken care by the memory management component of the operating system. And once a process completes its actions, then the process no longer exists. And when process no longer exists, then the memory occupied by that process is a waste of memory. So instead of that, it should be released and given for other process, because memory is limited and it is very precious. So we must ensure that the moment the process completes its task, the memory has to be deallocated. So this allocating of the memory, deallocating of the memory, and all this are taken care by the memory management part of the operating system. Then it keeps track of memory usage, how much memory is being used, where the memory is being used, and all that, so that it keeps track of free memory. And when a new requirement comes up, then it should be ready to allocate the free memory for the new requirements. And then it also must ensure that the two processes are kept in isolation. That means there should not be any overlap of the memory usage by more than one process. So every process should be allocated a unique memory, should not even by mistake one part of the memory should not be allocated to more than one process unless until it is required, what we call a shared memory. But as long as no such shared memory requirement is there, then each process should be allocated a separate memory, so that there should not be any misunderstanding, there should not be any miscommunication, there should not be any overriding of the data and corruption of the data and all that. So we must ensure that each process gets a different part of the memory, no overlap and all that. So that is also taken care by the memory management component of the operating system. Then comes the files, the file system, what logically we refer as a file is just a logical entity. It doesn't. We don't have to worry about where exactly the our information is stored in the secondary memory and all that, and how it is stored. We are not bothered about that. We are only bothered about file structure, like directories, how many directories are there in each directory, what all we have, and are talking about any particular file, then what is the path of that file from the root directory, how to reach that file and all that. That's a path of the file. So these are the things which matter to us. So when we are creating a file, we do require some actions to do. So in the back end, some memory has to be allocated, and that has to be put in the part of the directory system. The name of the file should be given, and type of the file should be given, and all that, and the access control, who should have what type of access control, whether anybody can only read or can read, write, or modify any such access controls are also to be decided under this file system management part of the operating system. So creating a file, deleting a file, reading a file, writing a file, and directory operations, all these come under the file system management. Then it also talks about the permissions for each file directory, whether the one owner of the file, what rights the owner of the file has got, what rights others have got. So usually we say that owner of the file can access the file in all possible ways, but others, we want others to only read only like thing, or they may read and write but cannot execute and all that. So there are three types of permissions: one for read, one for write, and one for execution. At the same time, there are different types of users, like normal user, outsider, and then the part of the group, and the owner of the file or the directory. So each one may be given a different access control permissions, and security uh, component of that is also taken care by the file system management part of the operating system. Then mounting the file systems, so how the file system is connected to the directory, which directory this file system is connected, all that. So we have a proper tree structure of the file system so that it becomes easier for creating and accessing any file, and a unique way of accession is possible for every file and all that. So these all are taken care by the file system management component of the operating system. Later comes the device management, where we keep talking about various IO devices connected to our system. So when you are connecting IO devices to the system, usually the IO devices will be very, very slow compared to the processor or the system itself. Then if we are interacting with any slower IO devices, then it is better to have some buffer memory in between the system and the IO device, so that if we are reading any data from the input device, then instead of making the processor keep waiting for each bit of the data to come in bit by bit or byte by byte, and takes a hell lot of time, so we can allow the IO devices to work with the buffer. So the input device is reading something, and then let the data read from the input device is first put on the buffer, and now and then the processor can take time and read the data from the buffer instead of waiting for the IO devices, which are heavily slower compared to the processor speed. Same way, caching and spooling are taken care by the device management. Managing the device driver, so each device behaves in a different way. So to ensure that the behavior of each device is properly understood by the system, we do have something called drivers, and these drivers are to be managed, and this is done by the device management system. Then comes the secondary drive, that's the storage management. The storage is divided into partitions, and then disk partitioning, formatting, and all that is taken care by the storage management, then space allocation, and then tracking. So if we want to write a file onto the secondary memory, and this file needs some space in the secondary memory, so which part of the secondary memory we can allocate the space. So it may be at a stretch, or it may be allocated at different partitions, different slots and all that, depending on the way the storage management is done. So many issues about the storage management we need to look at. So main action done by that is about how the disk is partitioned, and how the what is the format used for the disk. So if we know the format of the disk, then the communication between the secondary memory and the main system becomes possible. Then space allocation, and then tracking where the space is available and all that. And then scheduling, because if one file is stored onto the secondary memory, and if that file is stored in smaller chunks here and there or all over the disk, then you can just can't keep moving randomly as and when it is required. So if we have a proper movement of the disk possible, because basically disk is a mechanical system which works on a rotation, and the tracking is done by the heads, and all that movement of the heads, rotation of the disk and all that have to be taken care. So to make sure that the part of the file which are distributed all over the disk are read, and instead of reading in any random way, if we can read it in a proper way, then with minimum number of movements of the disk, minimum number of movements of the reading element, we can ensure that all the data can be read or written. Because movement means physical thing, physical means it's lethargic, and it is highly slow, and definitely the speed of this movement, head movement and all are totally incomparable with the speed of the processor. So make sure that all these activities are done as early as possible, so that the whole system works more efficiently. That is taken care by the descheduling component of the storage management of operating system. Yes, security and protection are major issues to be taken care by the operating system. So whenever a user tries to interact with the system, then the authentication, some login system has to be implemented, and make sure that this authentication system is highly secure, so that the whole system can be well protected. Then proper permissions and access controls for every part of the system should be very well monitored, and well defined, so that nothing goes wrong. Then isolation of the processes, as we discussed, so that also should be taken care. And finally, the networking part of that, the communication management. So we need some protocols, some standards to be set how two systems should communicate. Like example is, if we trying to communicate with another human, a human is trying to communicate with another human. So first thing required is a common language. Unless until we have a common language, two humans cannot communicate each other. Even that common language may be a sign language, or maybe any spoken language, but it has to be one common language, and that common language has to be decided prior to communication begins, and that is what we call a protocol. Protocols have to be defined, and this support of these protocols have to be taken. So when you are working with multiple systems and if they are interconnected, then we should ensure that each of the system is working under the same protocol. Only then communication is possible. If multiple people are trying to communicate with each other, then one thing is essential, that all of them should communicate with a language which each one of them can understand. So that's what we infer as a protocol. Then how to manage the network connection. So when we are trying to connect one system with another system, how the connection is done. So it can be a synchronous connection or it can be asynchronous connection. Many situations are there, many different versions are there, many types are there. So there are some elements like sockets and all that are useful for connecting between two systems. Yeah, it's a socket, not necessarily means the physical socket and all that. It's an logical name. The socket is a software tool that helps us in connecting two systems, which make sure that connections are run between two systems for using a proper protocol, having proper security system and protection system enabled, and all these. So this whole activities are under the control of networking management or the networking component of the operating system. So that's a overview of various functions that our operating system can give to us. So let's get into these one by one and see in little detail at this instant. We are not going in full detail. We are still in the introductory part of the session. So let's just get a bit better glimpse of what each of these are in coming sessions. Once we are through this, then we get into deep and see each of these components and how each one of them are implemented and what are the issues with each of these components and all that will be following in the future sessions. So that's it for now. Thank you.